Welcome to this video, Modelling with Quadratics. Here we're going to create a model that applies our knowledge of quadratics. Let's take a look at this question. A car travels south from home to the beach at its maximum speed and faces a 4 km/h headwind. This will slow the car down. On its return journey, the car travels north at its maximum speed, but is given a 3 km/h tailwind. This will speed it up. The total journey time is 1.5 hours. The beach is 10 kilometers from the house. We need to determine the car's maximum speed. To solve this problem, we're going to first make use of the fact that the total journey time is 1.5 hours. So the total time will equal the time south, its first part of the journey, and its time north, the second part of the journey. To work out we know the total time is 1.5, but to work out the time south, we're going to make use of the formula for speed, which has been turned around for the formula for time, which is going to be time is distance over velocity. So the distance travelled is 10 kilometers, and the speed of the car as it travels south will be its maximum speed minus its headwind of 4. Then we will add the time for the north, which is going to be its distance 10 kilometers, then its velocity of the car plus the tailwind of +3 that speeds the car up. So we end up with this equation which we need to solve. Now, to solve this, the first thing we should really do is to get rid of the denominators, the lower bits of our fractions. And to do this, we're going to multiply through the equation by v minus 4 and v plus 3. This gives us 10v plus 3 plus 10v minus 4. We now need to get rid of all of the brackets, so we need to expand and simplify. This gives us 1.5 v squared minus v minus 12 equals 10v plus 30 plus 10v minus 40. Next, we just need to get rid of that final bracket on the left-hand side, and I'm also going to simplify as well. This will give me 1.5 v squared minus 1.5 v minus 18 equals 20 v minus 10. Finally, we can see that this begins to pull together and look like a quadratic. So I'm going to put it in the quadratic form, where we have all of the terms, the x squared term, the x term and the number term on the left hand side. In this case, when our unknown is an x, it's v, so our v squared term, our v term and our number term will be on the left hand side, and we'll have that equal to 0. So when we do that, we get 1.5 v squared minus 21.5 v minus 8 equals 0. Now, on most of us use Casio calculators, and I'll include a link for the calculator that is recommended to use on this course. On this calculator, there is an equation solver, and we end up with the value that v is equal to 14.7 kilometers per hour. There's also a negative answer that we get with this question. However, the negative, the speed cannot be negative, so we have to take the positive answer. So our final answer is that the maximum speed is 14.7 kilometers an hour. Thanks for watching the video. If you'd like to know more about how we can use quadratics to solve harder problems, please come to kippersconsultancy.co.uk. Sign up, meet other students and tutors, have those harder questions answered, build your confidence and access high grades.